So the T cells are extracted from the patients using leukapheresis. Can you walk us through this process a little bit more?
So leukapheresis is in some ways similar to donating blood in a simple way. Um, Patient is connected with an IV, which is connected to the machine. And the machine takes a little bit blood at a time. It enriches for the cellular part, which it puts it in a bag, and rest of the liquid component, plasma, is infused back. And this circuit goes on for a period of time that gives us enough starting material for producing CAR T cells. So it's very, very similar to, one would say, when you go through blood donation.
And then the T cells themselves are taken to a laboratory and genetically engineered. Can you tell us a bit more about how this genetic engineering is done?
So genetic engineering has now evolved. It started around 30 years ago. But now it has evolved to a stage where it has become a quite standard routine practice. The transfer of the material happens through a lentiviral vector. So the T cells are put into culture in the right appropriate culture medium and also with growth factor similar to IL-2 and CD3, which stimulates the T cells. And then they are infected with the lentivirus. Now, lentivirus are modified that they are not going to be able to grow on their own. They just transfer the material, the DNA material, but are not able to grow. So there is a clear safety component that once it is in the T cells and when given to patient, they are not going to get a lentiviral infection. And so they are called replication deficient viral vectors. The cells, T cells, are cultured with lentivirus and then eventually washed and allowed to grow for a certain period of time. Large number of cells are infected, not all of them, but they're allowed to grow for anywhere from 10 days to 2 weeks. And when appropriate cell number is obtained, the cells are washed and then frozen in a bag and shipped to our facility for infusion when we are ready. Cells are frozen so we can decide to infuse whenever we would need to. They don't have to be given fresh.
And what is the length of time between that extraction and the infusion?
So usually it takes around 2 weeks, sometimes slightly over it. The little bit of time is required not just for growth of the cells and putting in the bag, but we also need to make sure that certain infection-related parameters are confirmed. So this product should not have any infection. The viral vector we have used is not active and is not proliferating or is not present in an abnormal concentration or number. And so after the product is done, they're put into bag. There's a simultaneous whole long list of testing which is done to certify that this product is safe enough to be given to the patient. So the whole process takes around a little over 3 weeks or so. We usually keep around 4 weeks time for everything to be finished. The certificate of its use is obtained, and then it's shipped here for the patient to be received.